This is a project explaining the chi-square test for homogeneity and association/independence for AP statistics. For the chi-square test for homogeneity, our test is applied to a single categorical variable for two or more populations. It is used to determine whether frequency counts are distributed identically across different populations or categories based on the data provided. Let's start with an example problem. Without getting too much into the details of this problem, we're testing for a difference in proportions for attending and resident physicians with the four categories frequent, occasionally, rarely, and never. We start this problem by stating the null hypothesis. In this case, our null hypothesis is that attending and resident physicians have the same proportions for each of the four categories. The alternative hypothesis is that some or all of these proportions are not equal. Since this problem doesn't explicitly mention a significance level, we use alpha equals 0.05. The next part of the problem is planning and checking our conditions. The first condition is that the data has come from a random sample or experiment. We are not explicitly told that this study is random, but we can assume this based on how it's conducted. Next, we determine that all expected values are at least 5. A common mistake is that students look at observed values instead of expected values when checking this condition. We can calculate the expected values by multiplying the row total and column total and dividing by the table total for each value. However, it is much easier to use a calculator to find these values. Before we show you how to do this, we'll go over the third condition, which is that the sample size for each category is less than 10% of its corresponding population size. It seems reasonable to assume that there are more than 490 attending physicians and 710 residents in training at a university medical center.
To calculate expected counts and p-value using a calculator, select Menu, Matrix, and Vector, Create Matrix. Select the number of rows and number of columns fitting to your data. Input the observed values. Now click Enter. Click Menu, Statistics, Stat Tests, and X-squared two-way test. For observed matrix, input answer or ANS. This will give you the p-value. Select var and stat.exp matrix to see your expected values.
If you use a calculator to conduct this test, you have to mention degrees of freedom, the chi-square value, and the name of the test, as well as the p-value. The degrees of freedom is the number of categories minus 1. The chi-square value is given by the calculator's output. Also, don't forget to mention the name of the test or you'll lose points on the AP exam. In order to do the conclude part of this exam, we need to state whether we fail to reject or reject the null hypothesis. Since the p-value in this example is less than the alpha value of 0.05, we reject the null hypothesis. In order to state our conclusion in the context of the problem, we say that there is statistically significant evidence to conclude that the distribution of unnecessary transfusions differs among attending physicians and residents.
To execute a follow-up analysis, select var and stat.comp matrix and enter to receive your values.
For the next example, we will perform a chi-square test for association to see whether there's an association between shirt color and deaths in Star Trek. We will use this data table for our problem. For the state step, we are testing the following hypotheses at the alpha equals 0.05 significance level. The null hypothesis is that there is no association between shirt color and deaths, while the alternative hypothesis is that there is an association between shirt color and deaths. For the plan step, we will perform the test after first checking that the conditions are satisfied. The random condition is met because we have a randomly selected sample of Star Trek crew members. The 10% condition is met because we can reasonably assume that 430 is less than 10% of all Star Trek crew members and 40 is less than 10% of all Star Trek fatalities. The expected counts, circled on the output below, are all at least 5, so the large counts condition is met. For the do step, based on the output, the chi-square test statistic is 6.189. The degrees of freedom, calculated using rows minus 1 times columns minus 1, is 2. The p-value is 0.045. Finally, for the conclude step, since the p-value of 0.045 is less than alpha equals 0.05, we reject the null hypothesis. Thus, we have convincing evidence that there is an association between shirt color and deaths in Star Trek.